How is the sample introduced? The primary purpose of the sample introduction system in atomic absorption spectrometry is to transfer a reproducible and representative portion of the sample into the atomizer at a very high efficiency. So what exactly do we mean by this? These are some of the methods: pneumatic, ultrasonic, electrothermal, hydride generation, direct insertion, laser, spark, glow, and for which type of materials it can be used. You can use it for solutions as well as powders as well as solids. Now this is what happens in nebulization. So what is happening? Your sample is introduced. You have a gas, say something like argon, and it is being spraying into a very fine mist, very fine particles. Okay. And this nebulizer basically is nothing but atomizer, which is introducing the sample into the flame as a fine mist. So there are different types of nebulizers. One of them, the pneumatic nebulizers, and in that you have all these different types: concentric, cross flow, fritted disc, Babington. Now remember one thing, all these types or all these nebulizers will have a sole purpose. And what is the sole purpose? The sole purpose is to divide the solution or convert the solution into finely divided droplets or mist, which is called an aerosol. So that is the main purpose of whichever nebulizer or sample introductory system that we are considering. So here in this case, don't be worried that there are so many types. All you have to remember is one of them, and you should be able to reproduce it in the paper. Don't panic that there are so many of them. So this is actually how these nebulizers look like. आपको होली के टाइम के पिचकारियों की याद आ रही होगी. This is what actually a nebulizer does sometimes. It is going to spray your sample into a very fine mist. So if you see this, this one is a better diagram. In this, what you have is, you have the solution uptake. Now in this, when the solution is coming at this very point, sorry, see, at this very point, there is a very fine gap between the solution entry and the gas which is coming out. So both are trying to come out through the same small space. And when they are trying to come out through that same small space, what happens is, due to the force of the gas inlet, this water is pressurized and split, or this solution is pressurized and it is split into very fine particles, which is nothing but aerosol. That is what happens in any nebulizer that you take. This is a concentric nebulizer, as the name suggests. You can see that there are two pipes placed one in another. The smaller pipe, the inner one, which is giving the solution, the outer one is giving the gas inlet, and together they are giving out an aerosol. Similarly, this is another diagram for capillary concentric nebulizer. You have a cross flow. Cross flow means, this is a better diagram. See, cross flow means this is a liquid sample that is coming and this is a gas that is spraying. So when both are going to come across each other, the gas which is at a high pressure will eventually split the sample into very fine aerosol. So this is a cross flow. Fritted disc. This you can see here is a disc. Okay. Now what happens is that if I keep this, if I have a vibrating say surface and I'm dropping a droplet of water onto it, what will happen? Due to the vibrations, the water will try to split into small particles. The same thing happens here. So what happens is the carrier gas is passed through the fritted disc and there are droplets here. So because of that, what happens is the sample gets split into small and tiny particles. This is the Babington nebulizer. This is a very what you say, funny name, but eventually the functioning is very simple. You can see this part. What happens is argon gas is pressurized. This has a larger area here. This one is a larger area, but it is coming out through a very small hole. Now when it is this large area, gas is pressurized through a very small hole, and the liquid is made to flow over the circular surface as a thin film. That time, this particular argon gas, which is coming out with the pressure, will try to split the sample into a lot of fine mist. Similar to the deodorants that come out from the deo can. It's similar to that. Or a perfume when you're spraying it out. What is it? It's a fine mist. It's being pressurized and coming out. So that is the function of your nebulizer. Then we have V-groove nebulizer, and we have ultrasonic nebulizer, in which you are providing an vibrating surface and the solution is being split into fine particles. So, any doubt in nebulizers till this point? If you want, I will just go through the diagrams. I just display the diagrams again. This is the concentric pneumatic nebulizer. Cross flow nebulizer. Fretted disc, Babington. V-groove. Again, the same technique here, only instead of your circular surface, you have a thin groove through which the liquid is coming down. Ultrasonic nebulizer. Okay. Any queries? Then just put an OK in the chat box so that we can move ahead. Okay, great. So let's move. The next is flame atomizer. So what exactly? Okay. So the flame method of supplying atom source utilizes a nebulizer in conjunction with air acetylene flame. Solvent evaporates, metal salt vaporizes and is reduced to complete the atomization process. So that is what your flame atomizers do. So this is something called as a pre-mix burner. I don't want you all to get into detail of this, but you should have the knowledge at least. This is a flame atomizer. So what exactly happens in this is, okay, so what is the laminar burner here in this case, or an flame atomizer? If you can see here that there is a thin capillary through which the sample enters. Now inside this sky blue color thing which you can see, you basically have a chamber where you are mixing your fuel, your oxidant, and it is being passed into this burner here. Okay. Now in that burner, here then the flame appears at this point. See, this is exactly what a laminar burner would look like, and this is the flame that would appear. So here you have different sample inlet, gas inlet, and your oxygen which would enter, and at this point the flame would appear. Then along with that, we could also have a graphite furnace. So what is a graphite furnace? It is basically also called as, in it, here you can observe, this is the platform on which the sample is placed, and this part is a hollow graphite tube, and this hollow graphite tube is heated, and when this is heated, automatically the platform also gets heated, and the sample that is placed on that particular graphite platform will also be heated, and then the radiations that are passing through it, P0, and the out is P, and you can measure the absorbance. So it operates similar to that of a flame, only that there is no actual combustion taking place inside it.